In this video, I will try to show how I extracted information from an unfortunate event that involved damage to valuable memorabilia from the local sportsman and hero Scott Jones. The damaged items were on display at the Creighton Pavilion in the installations of the amusement park. Two datasets were available, the first one being the movement and check-in data for the users, and the second one the communication between them. Both include the timestamp, which was converted to extreme times and date. The time of the crime was obtained, and so a list of the last visitors who were in the pavilion before the crime can be provided. The general behaviors of the visitors were studied, as well as the more specific, and some interesting patterns were seen. Before looking at the movement data and the communication data, let's have a general view of the park. Here are the locations of the attractions. All the movement data was divided by type of attraction and by zone. This helps to summarize the activities and interests the visitors in a lateral way. The Creighton Pavilion where the incident happened is marked at 32. The size of the circle represents the amount of visitors, and the map shows that a lot is going on thrill rides and in family rides. And when coloring by zone, we see that they are in the coaster and wet zone, also where the thrill rides are. As a side note, I used the Veridis color palette, which made the visualizations easy and friendly to the eye. The colors were assigned to zones and types, and the palette was always discrete. There was never a continuous or order variable that made me choose, for example, a gradient or transition palette like the one here. If the plots are put side by side with a histogram, it is easy now to see how large the visits really are. Now, let's look at the movement. This represents the current versus next check-in the users did. This is the general view. The following plot shows the moving behavior per type. The thrill rides are the most visited, followed by the rides for everyone, as the map previously showed. The rest of the facilities are much less visited, and the proportion is more clear with bar plots. Each color in the bars represents the amount of times a visitor moved from one zone to any of the others, and the proportions are similar for all zones. When looking at the same information group by zone, it's not surprising to see coaster and wet as the largest visited. After this general view, two levels of detail will be studied, per day and per attraction. A division of the two previous histograms per day shows that the largest activity occurred on Friday. The distribution of types and zones remained the same. I really liked this simple plot because it's showing so much information. The location from, it's on X. Its frequency, it's on Y. The location to is shown by color, and then the small multiples per day. 4 variables in one simple view. The detail per attraction gives an insight of the park movement in the park. This is very helpful to identify specific behavior. The heat map is ordered per zone of origin, but the colors are per destination zone. The intensity of the colors is the amount of times this combination happened. The plot shows many pink and brown colors, the thrill and everyone attractions, and fewer for the teal, which is kiddie, and purple shows people who are in the columns of thrill tend to move a lot to any other type. The kiddie column moves to all except pink, thrill, and the people from everyone will rarely go to the kiddie rides. This behavior is observed in the tundra and wet zones. This plot is giving a lot of information also. The attractions from, where, and to, were, the frequency via color intensity, and the area or type via color. A histogram showing the frequencies makes the measuring easier than the shades. In an interactive mode, a user will be able to select the level and the classification colors through a menu. Even though the first analysis was performed with the movement data, the communication dataset gave important information about the crime. The plot of all of the communications is showing per color how many communications there are throughout the day. It can be seen that the distribution of the calls are similar throughout the day for all the 3 days, and that most of the communications are coming from the wet area, despite the fact that the coaster is the area with the most traffic, as we saw in the movement data, and also despite that Friday was a date with a lot of activity. Nevertheless, there is a large peak on Sunday in the middle of the day. This is a strong indication of something outlying. A most interesting plot arises when looking at the information by second. In this simplest plot, I found the intermittent pattern that allowed to find the special units. Right now, I was running out of measurements, so the next variable that I hadn't touched was visitors. The next two plots show 2 strange colors and 3 strange receivers. When I look at them, I had a eureka moment where I could see where the strange pattern comes from. The following plots will show information for both IDs in different levels: time of call, SON, the receiver of the calls, and the senders of the calls. The users 1278894 and 839736. Here we see time and SON of calls sent, to whom they are calling, and who is calling them. These are the interesting things. Both of them are always sending the calls from the entrance zone. Both of them communicate with all or most users. They receive calls from everyone. ID I39736 is not periodical. It is the instance generating the communication peak on Sunday around the time of the incident. I label it as emergency unit. The emergency unit will give the time of the incident. The ID 1278894 has a very regular pattern, and it's receiving periodical signals from certain zones at certain times. I will label it as a broadcaster. The senders of the information to the broadcaster can have a special behavior. Both units are sending information to most users every day. A clear step pattern is visible on the user's ID per day, which should be further analyzed, and I will very likely separate the users in these three groups. The external group does not have a special pattern, except from the large amount of calls received at the moment of the incident, likely due to panic. When separated, users labeled regular are not showing any hidden behavior anymore throughout the times of the day, and the communication is, let's say, normal. Even the peak of communication at the moment of the incident is smoothed out. The communication plots showed that the incident occurred at 12 p.m. in the time of my system. It was very hard to zoom in these plots, so I extracted the top hours from the set. Based on this, I returned to the movement dataset and filtered all the users who were seen at the pavilion 1 hour before the incident, and this is how I combined both. The following plot shows the movements of these users during the weekend. It's recommended to interview these visitors and look at them closely. For example, user 3336607, who visited all the areas in very one small period of time. There are still more things to discover. Remember the strange pattern at the broadcaster? There is a difference in the amount of users who contact the broadcaster every day. The number of calls these users make is also very clearly separated in steps. I will use the IDs of these groups of users to analyze their movements in the day, redoing my plots, now separated by groups, to observe their preferences.